Imagine this: Jupiter, the largest planet in our solar system, hurtling towards Earth. It's a scenario that seems almost too wild to consider, but let's take a moment to dive into this thought experiment. It's a scenario straight out of a science fiction disaster film. The kind of plot that would make for a blockbuster hit, filled with suspense, drama, and unimaginable destruction. But what if it wasn't fiction? What if Jupiter, with its massive size and gravitational pull, actually collided with our planet? The sheer thought of it sends shivers down the spine. The consequences would be nothing short of apocalyptic. The impact would release energy beyond our wildest nightmares, causing a chain reaction of catastrophic events. Let's delve into the science behind this hypothetical cosmic catastrophe. Scientists have long studied the movements and interactions of celestial bodies, and while a collision of this magnitude is highly improbable, understanding the mechanics can be fascinating. It's a terrifying thought, but also an intriguing one. The idea of such a massive object moving through space towards us sparks both fear and curiosity. The sheer scale of such an event is hard to comprehend. Jupiter is a gas giant, a behemoth in our solar system, dwarfing all other planets. We're talking about a planet so large that it could fit over 1,300 Earths inside it. Its volume is immense, and its gravitational influence is equally staggering. Can you even begin to imagine the forces that would be unleashed? The gravitational pull alone would cause massive tidal waves, earthquakes, and volcanic eruptions long before the actual collision. Let's explore the reality of Jupiter and its place in our solar system. Understanding its composition, its role, and its interactions with other celestial bodies can give us a deeper appreciation of the delicate balance that keeps our solar system in harmony. Jupiter is primarily composed of hydrogen and helium, much like a star. It's often referred to as a failed star because it didn't acquire enough mass to ignite nuclear fusion. Its atmosphere is a swirling mix of gases, with storms that have raged for centuries, like the famous Great Red Spot. These storms are so vast that they could engulf Earth several times over. Jupiter also has a fascinating system of moons, each with its own unique characteristics. Europa, for instance, is believed to have a subsurface ocean that might harbor life. So while the idea of Jupiter plummeting towards Earth is purely hypothetical, it serves as a reminder of the incredible forces at play in our universe. Forces that shape planets, stars, and galaxies, and that continue to inspire awe and wonder. Jupiter is a gas giant, composed mainly of hydrogen and helium. This massive planet is the largest in our solar system, and its swirling clouds and storms are a testament to its dynamic atmosphere. The planet's iconic Great Red Spot is a gigantic storm that has been raging for centuries, showcasing the immense power and energy within Jupiter's atmosphere. It's a behemoth, with a mass over 300 times greater than Earth's. This colossal size means that Jupiter has a significant influence on the solar system, affecting the orbits of other planets, and even protecting Earth from potential comet impacts by pulling them into its own orbit. To put that into perspective, if Earth were the size of a grape, Jupiter would be a basketball. This comparison helps us grasp just how enormous Jupiter truly is, dwarfing our home planet in both size and mass. Its immense size is only part of the story. Jupiter's atmosphere is a complex and turbulent place, with winds that can reach speeds of over 300 miles per hour. The planet's rapid rotation, completing a day in just under 10 hours, contributes to these extreme weather patterns. Jupiter's gravity is also incredibly powerful, more than twice as strong as Earth's. This immense gravitational force not only shapes the planet itself, but also has a profound impact on the surrounding space. That means if you weigh 100 pounds on Earth, you would weigh over 200 pounds on Jupiter. This dramatic increase in weight is due to the planet's strong gravitational pull, which is a result of its massive size and density. This gravitational pull is what keeps its numerous moons in orbit and plays a crucial role in the dynamics of our solar system. Jupiter has at least 79 moons, including the four largest, Io, Europa, Ganymede, and Callisto, known as the Galilean moons. These moons are fascinating worlds in their own right, with unique characteristics and potential for harboring life. Jupiter's influence extends far beyond its immediate vicinity, shaping the structure and evolution of our solar system. So how can something so massive and powerful just stay up there in space, seemingly posing no threat to us? The answer lies in the delicate balance of gravity within our solar system. Each planet has its own gravitational pull, and these forces interact in complex ways. The Sun, with its immense mass, exerts the strongest gravitational force, keeping all the planets, including Jupiter, in orbit. Think of it like a giant cosmic dance, with each celestial body moving in a carefully choreographed pattern. This balance ensures that planets, despite their gravitational attraction, maintain a safe distance from one another. But what if something disrupted this delicate gravitational balance? What if a rogue star or a massive object passed close enough to our solar system to nudge Jupiter off its course, sending it hurtling towards Earth? It's a highly unlikely scenario, but not entirely impossible in the vastness of space. If Jupiter were to be knocked out of its orbit, the consequences for our entire solar system would be catastrophic. The planets would be thrown into disarray, their orbits destabilized, and collisions would become inevitable. But for us on Earth, the focus would be on the impending doom approaching from the outer reaches of our solar system. Section 5. The beginning of the end, Jupiter's approach. As Jupiter drew closer, the world watched in awe and terror. Its gravitational influence on Earth would become increasingly apparent, altering the very fabric of our planet's stability. Tides would become more extreme, rising to heights never before seen in human history. Coastal areas would experience massive floods, submerging cities and displacing millions of people. Earthquakes and volcanic eruptions would become more frequent and intense, shaking the foundations of our civilization. The planet's crust would be subjected to unimaginable stress, causing it to crack and shift violently. The night sky would be dominated by the ever-growing presence of Jupiter, a constant reminder of the impending catastrophe. It would appear as a brilliant, ominous orb, casting an eerie glow over the landscape. Its swirling clouds and great red spot would be visible even to the naked eye, mesmerizing yet terrifying. The once familiar stars would be lost in the glare of our impending doom, their light drowned out by Jupiter's overwhelming presence. The sense of dread would be palpable, spreading like a shadow across the globe. As the days grew shorter, the rhythm of life itself seemed to falter. The end drew near, and humanity faced its greatest challenge yet. The world braced for the unknown, united in fear and hope. Scientists worked tirelessly to understand the changes, while governments issued emergency broadcasts, urging people to prepare for the worst. Families gathered, seeking solace in each other, and communities came together, showing resilience in the face of impending disaster. Historical records and ancient texts were revisited as people sought answers and prophecies that might explain the cosmic event. Technological advancements and space missions provided new insights but also highlighted the limitations of human knowledge. In this time of crisis, a sense of global unity emerged, reminding us of our shared humanity and the fragile nature of our existence. Amidst the chaos, there was hope. Hope that future generations would learn from this, and that humanity would endure, no matter the outcome. From the vastness of space, Earth and Jupiter's dance was a stark reminder of our place in the universe, a testament to the delicate balance of life. Section 6. Earth's final curtain call, the inevitable collision. The moment of impact would be instantaneous and cataclysmic. The energy released would be equivalent to billions of atomic bombs detonating simultaneously. Earth's crust would be ripped apart, its atmosphere blasted into space, and the oceans vaporized. The sheer force of the collision would be unimaginable. Imagine the entire planet being crushed under the weight of a giant, only the giant is 300 times more massive than Earth. The heat generated would be intense enough to melt rock, and the shock waves would reverberate through the solar system. And Section 7, the aftermath. A solar system in chaos? In the aftermath of this cosmic collision, Earth would be reduced to a molten, lifeless wasteland. The debris from the impact would be scattered throughout the solar system, potentially creating rings around Jupiter and bombarding other planets and moons. The delicate gravitational balance of our solar system would be thrown into chaos. The orbits of the remaining planets would be altered, potentially leading to further collisions in the future. The once orderly system would become a cosmic billiards game, with unpredictable and potentially catastrophic consequences. Section 8. Life after Jupiter, could anything survive? The short answer is no. The extreme heat, pressure, and radiation generated by the impact would obliterate any and all forms of life on Earth. Even the most resilient microorganisms, which have survived within Earth's crust and deepest oceans, wouldn't stand a chance. the Earth we know, teeming with life and diverse ecosystems, would be gone forever. It's a sobering thought, a reminder of the fragility of life and the power of the forces at play in the universe. Section 9. Beyond the destruction lessons from a cosmic hypothetical. While the scenario of Jupiter colliding with Earth is highly unlikely, it's not without its value. It serves as a stark reminder of the power of the cosmos and the importance of understanding the forces that govern our universe. By studying celestial objects like Jupiter and understanding the laws of physics that dictate their movements, we gain a deeper appreciation for the delicate balance that allows life to exist on Earth. It also underscores the importance of continued space exploration and the search for potentially hazardous objects that could threaten our planet. Section 10. Our place in the universe. A reminder of Earth's fragility. Thinking about cosmic events like this helps us put our own existence into perspective. We often take for granted the stability of our planet and the preciousness of life. But the vastness of space, with its countless stars, planets, and celestial objects, serves as a constant reminder of our cosmic insignificance. It also underscores the importance of protecting our planet, the only home we know, from both internal and external threats. Section 11. Conclusion. The importance of understanding cosmic events. The hypothetical collision of Jupiter and Earth is a terrifying thought experiment, but it's one that can teach us valuable lessons about the universe we live in and our place within it. By studying the cosmos, we gain a deeper appreciation for the fragility of life, the power of nature, and the importance of protecting our planet. And who knows, maybe someday, our understanding of the universe will be advanced enough to prevent such a cosmic catastrophe from ever happening.